Hey guys, David here and welcome to another video. I am back at it again, building a crazy computer build, and you've already seen quite the montage of me struggling with various things. But now I just kind of want to give some explanations and give you some insights into what it is that I'm trying to achieve. I also want to give a big thanks to PCBWay. They make very high quality PCBs for a super affordable price. You can get 10 pieces up to 10 by 10 centimeters for just $5, which allows you to get your PCB projects done much easier. They also offer manufacturing services, so if you're looking to have some stuff 3D printed in almost any material you can imagine, including almost all plastics, a bunch of resins and also metal, then go ahead and check out their manufacturing services. Everything will be linked down below. The title Posthuman for this build is kind of referring to the whole brain in a jar concept from SciFi, where you have a brain in a jar that is connected to some sort of computer and basically thinks it's living its normal life, but actually it's just a brain in a jar. And kind of my twist on it is that here is the brain in a jar, but it also is the computer, and then in the back will be what will be the computer, and that's going to be kind of a radiator and some ports, and the whole thing is in kind of a steampunk aesthetic, as I think that fits this theme really beautifully. Now you might already be kind of thinking it, why put it in a vat like that? Isn't that terrible for airflow? And well, yes, it is terrible for airflow, but I'm not planning on using air for the cooling. Instead, I will be using mineral oil. This will make it so much more authentic and actually look like a vat. A lot of people already commented that down my cryo PC build that it would have been cool if I put mineral oil in it. Well, that would not really be feasible for that kind of a large computer with a bunch of stuff happening. For this build, it is great. Mineral oil is not something that is very easy to work with, however, and I will go much more in depth about it in a later video when we actually get to putting any sort of oil in here. But the short of it is that you need to design every little aspect of it very precisely so that you don't have a giant mess in the end. For now, let's talk a bit about the hardware. Since this is very small and I still wanted to have enough space to kind of put some aesthetic elements in there, like this brass kind of artistic brain that is in there, I did not have space for a GPU. Well, that is kind of a bummer. In the current market situation, this is probably more of a blessing, since it's kind of impossible to get a GPU at a decent price anyhow. Now, the CPU that I'm going with is Ryzen 5 4650G. That means it has the integrated graphics. And well, this chip usually is only available through OEM manufacturers. Our local retailer actually had it in stock and was quite cheap as well. But it was not without troubles. This motherboard only officially supports it in one of the most recent versions of the BIOS, and after flashing that it still did not work. I had really weird issues with it not recognizing the NVMe boot drive, and I hunted bugs for hours and hours in contact with various tech support, and in the end Gigabyte actually sent me a unreleased beta BIOS that fixed it, and now it is working perfectly. And the memory modules themselves is just 16 gigabytes of some generic things like Crucial Ballistic or something. I've already made a video about the custom heat spreaders that I made for this, which are custom metal 3D printed by PCBWay. If you haven't seen that video already, make sure to go check it out. It'll be linked up in the cards and down in the description. And the last component, of course, is the power supply. And well, SFX was the obvious choice, but even this cute tiny little 400 watt SFX power supply from Be Quiet was still quite large. But kind of having a look at it, I noticed that the height of it, which is the main limiting factor for me, is mostly wasted. So I stripped it out of the enclosure, took away the fans, since that is not quite as necessary inside of mineral oil. I was able to cut one of the heat spreaders down a little bit, and what I was left with is quite a small package. This will easily fit behind the motherboard and will be able to supply everything with power. Now just even the cables that were stuck on there would kind of fill up everything and would make it look really ugly. So I will be, of course, custom making all the cables. I will be soldering them directly to the power supply and going to the components. There's not a lot actually, there's just the 24 pin and the 8 pin and something for the pump, maybe it's the fans. So I will just custom make these to length and then sleeve them. So that will be a fun thing to try as well, since I've never actually custom sleeved myself, always just used extensions. For the cooling loop, as you can see here in front of me, I'm of course going to be using copper tubing and these little angle connectors, and that will allow me to go from the pump up through the radiator and back on top of the CPU. Now, right now I just have the stock cooler on there, but I won't actually be using that later, of course. I'll be custom designing something that should be really epic, so stay tuned for that. Now, apart from just not 3D designing everything in advance, I also employed some new skills that I had not really done much before. And the most obvious of those is brazing or soldering brass. You can see that this brain shape where the computer is mounted in is all made out of this like 4mm brass wire or rod, whatever you want to call it. And so it was quite easy to bend this to shape. Most of it was able to do just by hand, and the rest kind of with some pliers. And when I kind of got to the limit of how we wanted to bend, you can just simply heat it up and then they cool down again, and that way you can anneal it, release some of the stresses, and then it's a lot softer to bend again, as brass does work hard when you bend it. Then the actual brazing was a bit more of a challenge. I started off trying to use electronic solder, which has a very low melting point, but I couldn't really get it to flow that well, as the flux that I was using was actually more meant for brazing, and the melting point of the flux was almost higher than the one of the solder. So I kept making the joints too hot for the solder and still not having it flow very well. And to add insult to injury, after I painstakingly assembled the motherboard tray, it kind of fell apart when I was trying to sand it. So I remembered that I still had some proper brazing wire laying around, and since the gas torch that I'm using easily can achieve hot enough temperatures, I moved on to brazing. And while it took some trial and error, in the end I figured out how it works, and it's turning out a lot better. One of the biggest challenges was not just the soldering itself, but how do you hold this in place? These are a lot of parts that meet at odd angles, and it was easy enough when the motherboard tray was just flat on a piece of stone, but then adding these 3D elements, I needed to use a bunch of stone to kind of hold it in place and try to be able to access it. It was a bit of pain, but I think it should be absolutely worth it. And with that, I think all that's left for this episode is to tell you to go subscribe down below so you don't miss any of the future part of this. Might be a couple of weeks or even a month or so till I can release more videos of this, as progress is kind of slow. I'm doing other projects on the side, but I think this build is going to turn out really epic and might even surpass my Cryo PC. We'll see. Apart from that, if you have any suggestions, questions, comments, leave them down below. Hit the like button if you liked it, and I'll see you guys next time.